So basically, we use RSDLC to help us build our robot, which is robotics in development lifecycle. So the first step of the RSDLC is goal and our purpose. So our goal is to make a theremin, which is an electrical instrument. So when I bring our hand closer, it'll make a higher pitch, and our hands further, it makes a lower pitch.
The second step was design. So we had to design the theremin, and we got a schematic, and we had to build off it to make a theremin. And the way the theremin works is there are two oscillators. One of the oscillators is a fixed frequency, and another oscillator is a variable frequency. And they get combined, and then a mixer finds the difference between the two frequencies, and it outputs that to the speaker.
Yeah, and building the breadboard and using pieces, like transistors, resonators, capacitors, and jumper cables to connect them all. We pieced them together using schematics which could tell us where do we put the pieces together. Some of the problem we had during the camp is that we got some problem in the mixture where the frequencies get added and subtracted. But the mixture worked, and we fixed it, the mixture, by adding new transistor because the old one was broken.
So the fourth step is the program. Some of the programs we use is Raspberry Pi, the Arduino, and SolidWorks. For the Raspberry Pi, we light up LEDs to make certain patterns. And for the Arduino, we also did light up LEDs for certain patterns, and also get to use some servo motors and move some robots. And for the SolidWorks, we have been designing our own very unique objects that we can print in the 3D printer, but it didn't get printed today, so maybe somewhere in life.
And also, here is a demonstration of the Arduino. So, I combined two Arduinos because it's two projects, and they have one power source, and this is what it does. And also, you can change the volume. So there's this special program for the Arduino that lets you program it. So here, there's like this special software that lets you program the Arduino, and I use that to make that speaker.
And the last step is rethink and analyze, which allows us to make our project better. So we thought of, if we had time, we could have made two antennas, so we can make two notes or two tones at the same time, making more music and more tones. So some ways that the theremin can be used as is that it's a maybe key to the future, making new and technology for music and replacing classical instrument. So there's electrical violence, so why cannot we make a trumpet, electrical trumpet? So yeah, so this basic design can lead us to the future.
So we built the theremin on a breadboard, and the breadboard can be used to build prototype circuits. Here's a bunch of random components. So you just put the components in, and you don't have to solder, because soldering is a lot harder, but it's used to make permanent circuits. So here are some soldered circuits on a perf board. So, and to make into solder circuits, you use a soldering iron. So you plug it in, and you melt metal, like you heat it, and it melts and it sticks in place. And now our current state of the theremin is it's not working because we were missing an inductor, but it still changes in frequency when you touch it, but it can't detect your hand unless you touch it. So here is a demonstration. So if you see that's a frequency at 1 million hertz, which means 1 million times a second that happens. And as you see, when I touch it, it instantly becomes lower. So the way it works is it kind of acts like a capacitor, and what a capacitor does is it stores voltage, and capacitors are used to make oscillators. So the way a capacitor works is there are two metal plates, and the charge gets stored in between them. So your hand is one of the plates, and the antenna is the other plates, and depending on how far away your hand is, that changes how much it can store and make me change in the frequency.
Any questions? You guys did a great job.
Give them a round of applause. The great presentation, guys.